Hey, what's up, guys? This is Chung here again. This time number 1850. Minimum adjacent swaps to reach the case smallest number. So you're given like a string num, right? And an integer k, okay? And your task is to find, so, so the first step, right? So the k means that we need to find the case greater permutation, right? Starting from this number. For example, this is the number we have here, and the next greater permutation is 214, right? And then the next one is 241, 412, and 421, right? So this is that we can keep going, and we need to find the case one, right? In this case, like k is equal to 4, and this is our target, and we need to find the minimum number of adjacent digit swaps that needs to be applied, right? So that we can convert the original one, right, to this case one. So in this case, like we have this kind of this original one. This is our target, and the answer is 2. So how did we get that, right? Basically, all the others are the same. So basically, we're just trying to get from 1 to 4, 1 for 2 to 4 to 1. So this one it's simply just like a simulation. There's no fancy solution here. Basically we start from the left, from the first one. Yeah, basically we start from the first one, right? I mean, this is our and this is our target, right? And every time, we start from left to right, whenever the original one is not the same as the target, we know we need to do some swap, right? So how can we find that? Basically we simply use a greedy approach. Since this is the one we're trying to set, right? We know this one is different as this one, and so we know we want the 4 to be here. Okay, and how can we find 4? So basically, we start. This is the target place, and then we just try to find the first 4 on the right side, right? I mean, in this case, it's this one, and once we find that, we simply just bubble this one to this correct location. We do a swap, right? And then we keep going, and then after that we know, okay, so we have the correct letters on this location. Then we start checking this one, and then so on and so forth. Yeah, just like how exactly what we're going to do, right? So we simply basically try to a swap, right? Adjacent letters one by one until we have placed all these letters, the numbers or the numbers to its correct location. Yeah, I think that's basically the 2 steps, right? So first we need to do like case next permutations, k times next permutations, and then we simply do this like simulation movement, right? And regarding the next permutation, I think I have already talked about that in one of my previous videos. I will just briefly talk about that. So to find the next permutations, so what do? We start from the end. Let's say we have, it doesn't really matter. Let's say we have 5, 4, 5, 8, 6, 4, right? So how do we find the next permutation for this one? So basically we start from the end, right? And we find the first index who is smaller than the previous one, right? In this case, it's what it is. It's this one. This is the first index starting from the end who is smaller than the next one, because and then this is the place we know, okay, we want to place a bigger number here. Okay, and then what's the next step? The next step is to find like the first greater number again, right? From the end. So then we swap those two numbers. In this case, it's what? So we have this one going forward. So 6 is the first number, first letter, or the number who is greater than this 5, right? And then what do? We swap, because this one, since this one is increasing, remember. So on the right side of 5, everything is increasing, that's why. And we want to find the smallest one who is greater than this one, because we're trying to find the next permutation, which is smallest one who is greater than the current one, right? That's why we want to, starting from the end to the left, we find the first one, which is the smallest number who is greater than 5. Okay. And then in this case 6. That's why we swap those two. Now we have 6, 8, 5, and 4. Right? But this one is not the smallest, right? Because as you guys can see, the smallest is what? 6, 4, 5, 8. This is the smallest one. Because again, right, after swapping these two numbers, the remaining parts, this part is also in the descending order. Right? And to be able to find the smallest one, and we have to reverse this one, so that this one is like the next greater permutation, right? Okay, cool. So, and that's basically 3 steps to find the next permutations, and then we just do this one k times, and then we just try to move everyone into its correct location. That's the basic idea for this problem, and let's start coding then, right? First, let's implement that next permutation, right? This one is exactly the same as one of the LeetCode problem. I don't remember the numbers, but you guys can check that out. It's exactly the same idea here. So the index, like I said, we're gonna have like swap, find the index to swap. I use index 1 equals to -1, right? So like I said, we're going to start from the end, right? N minus 1, and then we start at 1, n minus 2 maybe, and then we stop at -1, right? At 0. Okay. Basically, if nums of I, right, it's smaller than the nums of I plus 1, right? And then we know, okay, so the index 1 is equal to I, right? And then we break. That's how we find the index 1. And the second one is that, if index 1 is not equals to -1, right? Because it could be possible that we don't have to do the permutation, right? Because, if we cannot find the index 1, it means that there's no next permutation. It means that it's all descending order, right? Which means there's no next permutation. Okay. So if this one is not equals to -1, then we need to find the index 2, right? So the index 2 at the beginning, it doesn't really matter. We can give us -2 as well. And then from the end, right, we do another like search, right? From -1 dot 0, right? Not 0. Right? It's start the ending. Oh yeah, we can use 0. It's okay, because it will stop. Actually, it will stop before the index, right? Before the index 1, because because we have already find, like, we know on the right side there must be a number which is greater than the index. So here 0 doesn't really matter, because we will break before the index 1. Okay. And then we check if the nums of I, right, is greater than the nums of index 1, right? Like I said, that's the first letter, first number who is greater than the current one. Then we find the index 2 in this case, right? Equals to I, and then we break again, right? So basically here, find first number starting from the end. Find the first number who is smaller than nums I plus 1, right? Oh, and one more thing. Since this num is string here, in Python, the string type is immutable. That's why, in order to make some swaps, we have to convert it into like a list type. So in my case, I'm just going to use a num is going to be a list of num, okay? So that I can just basically swap those elements. So here, again, starting from the end, right? Find first number, right? Who is greater than index 1, right? And then we swap, right? Swap. Maybe nums dot index 1 and then nums index 2, right? 2. Here, just copy and paste, right? Index 2 and index 1. Okay. And after this one, what do? We reverse, right? We reverse from what? From index plus 1 to the end. To the end, which is n minus 1, right? Index 1 plus 1, actually. So, and we can just maybe write like helper functions here, to do the reverse, or I think Python has like a built-in function, So while L is smaller than L, this one is pretty straightforward, right? Actually, it's just to do the swap, right? From two side, right? L R and L, okay, and then we L plus 1 and R minus 1, okay. That's the helper functions here. So now we have this kind of next permutation method, and we just need to do it twice. Sorry, not twice, k times. While k, and then we do a next permutation, right? Permutation, the k minus 1, right? And and one more thing, since we need to, in the end, we want to compare both the new one, the target one, and the source one. Probably I'm going to like make a copy of the original one. Dot copy. Oh, so one more thing in Python, you cannot simply assign this one, because this is equal sign assignment. It's like a reference. It's not like a value. If you do this one, whenever you change the nums, you do a num swap, it also updates old num. So that's why we can use a copy, to do a deep copy. Okay. Now we can simply try to move each number to its correct location, right? So the answer is 0, and for I in range of n, right? Do we have n here? Oh, we need n here. Okay. Length of nums, right? So like I said, if the nums of I is not equal to the old nums of I, right? It means that, okay, this one needs to be moved from the old ones, right? And how can we find the place where we want to move, right, from the old string? So that's why we're gonna have like j equals to I plus 1, because we want to start from the next one, right? While the old nums I, right, is not equal to the old nums j, right? It's not equal to the nums I. We move the j's forward. So once this while loop is finished, now the j is pointing to the first letter or the first number in the old nums who matches the current one, right? And that's the one we want to bubble it up to the current location, right? Basically find the first letter in odd nums, right? Who that matches, right? Current number, right? And then we bubble, right? Bubble that number to the current position, right? So how do we do it, right? We simply do a while j is not equal to I, right? That's how we do the update, and then we remember we're updating the old numbers, right? Not the new one, because we were trying to update move the old number into the new numbers. So this j gonna be a old number of this j minus 1, right? Equals this old because we're only allowed to swap the adjacent one. That's why we have to swap it like one by one, right? And then once this one's done, we move this j to the left, and then we also increase the answer by 1, right? And then lastly, just return the answer. Okay, cool. Yeah, I think that's it, right? I mean, let's see. Yeah, that's it. Let's run the code. Accepted. Submit. Yeah, there you go. So it passed, right? So for the time complexity, so this n and the k is like 1,000, right? I mean, to k permutations. So this one is what? It's like n, right? I mean, this one is like time complexity is n to do the next permutation. Yeah, because we find this one, it's like just some parallel for loop here, right? And then in the end we have a reverse. That's why the time complexity to find the next permutation is n, and we do it k times, which is another like n. So we have n square here, right? And this one is just like n, right? So that's why the total time complexity is like O of n square. Yep, I think that's it, right? For this one. Yeah, basically it's combined two problems into one. First one is to find next permutation, right? And the second one is that how can we move the how can we convert one string into another by only allowing to swap the adjacent uh, letters, right? I believe there's like similar problem in LeetCode. I don't quite remember what it is, but I think they're like a similar one to use a similar idea here. Cool. I think that's it for this problem, and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.